Hi, I'm George. Welcome to Production Ready, a channel where we discuss topics about making production-level software applications. This is a series of 10 videos starting with a basic to-do app written in Node.js and React that runs on your desktop. In subsequent videos in this series, I'll show you how to turn this simple app into a production-level application that's ready for millions of users with test and build automation, logging, security, and much more. First, let's take a look at what we're trying to build today. This is a very stereotypical to-do app that you may have seen before. A user can add a new item, mark the ones that you have finished as completed, update the name of an existing to-do item, or simply delete the ones that you don't want. For this video, we're going to use MongoDB as the database to store the to-do items. On top of that, we'll have a server that connects to MongoDB. The server will be written using Node.js and Express, and will provide REST endpoints to create, retrieve, update, and delete these to-do items. Finally, we'll build a front-end application using React.
Let's start coding. First of all, let's make two folders, one for front-end and one for back-end. Also, make sure you have npm and node installed. Let me show you which versions I have. Finally, make sure you have MongoDB server installed. I'm going to run it right now in a different terminal. The command is MongoD. Alright, now we're ready to start building the back-end code. We use the npm init command to begin a new project. Next, we're going to install Express, CORS, and NoDaemon. Express is a server framework that we're going to use to serve the to-do app endpoints. CORS is a package that allows us to enable cross-origin resource sharing from our React app. In essence, it allows our React app to be able to talk to our server. NoDaemon is a package that restarts the server automatically whenever any source code is changed. Now let's create a folder called source and create a blank index.js. I'm going to copy some code to index.js, which simply starts the Express server. As you can see in the beginning of this file, I've imported Express and CORS. And since we're going to be building a REST endpoints, this line tells Express to use a middleware that parses the request body as JSON. The next part is the CORS configuration. This allows the React app that will be running at localhost at port 3000 to talk to our endpoints. Now let's try it out. Oh, before we start, we need to update package.json and add a start command that uses NoDaemon to run this file. So let me update that. Okay, now let's give it a try. As you can see, the server is now running on port 4000. I can run the curl command from another terminal that calls localhost at 4000. Now we get an error that says the request has failed, and that's because we haven't built any routes yet. But at least we know the server is running. Okay, let's try to connect to MongoDB. For that, we're going to need a package called Mongoose, which is a very nice package that allows us to connect and configure a schema in MongoDB. Now we can go back to the code and add Mongoose. Before the server starts up, we want to initialize the connection to MongoDB. Here we have configured to talk to a Mongo database called To-Do app that's running on localhost. Let's restart the server. As you can see, it's able to talk to a Mongo database. Now let's create some routes. Let's create a folder called routes and add a file called todo.js and restart the server. This file is the controller for the to-do resource and will be responsible for all the CRUD functions. First, we have the to-do schema defined. For this app, we would like each to-do item to have a name and a completed flag, which is Boolean. Next, we define a model based on the schema. And this is our first endpoint, which allows our React app to post the to-do, which creates a to-do object in MongoDB. In this function, it's going to create a new to-do object and saves it to the database. Let's go back to index.js and add a route to the Express app. The server has restarted automatically. Now we can test it out in Postman. Here we're sending a post request to localhost at 4000 with our new to-do object. Hit send. Seems like it's working. Let's check out the database. Great. Let's create another endpoint. This time we're going to add the get endpoint, which returns all the to-do items as an array. Inside it runs the find function of the to-do model. Hit save. Let's check it out in Postman. Hit send. It returned the first to-do item that was added. Let's create a new to-do item called buy milk. Hit send. Call get again. Indeed, it's returning both items in the database. Let's check the database to make sure. Great. Now we're ready to add the third function, which is the put function. This allows the React app to update an existing to-do item, given an ID. First, it checks to see if the ID is valid. Next, it calls the model's find by ID and update function, given the ID and the request body. If it's successful, it will return the updated object. If not, it will return an error message. Let's try it out. Let's update an existing object by copying the ID and putting into a new request with the put method. We're going to rename the item to be buy a dozen eggs. Hit send, it works. Let's check the database to ensure that the name has indeed been updated. Let's call get again. Indeed, it's returning buy a dozen eggs. Last, we're going to create the last function, which is the delete function. The delete function works similarly to the put function, with the ID being in the URL. Again, it checks if the ID is valid and call the find by ID and delete function to delete the to-do item with that ID. Hit save. Now we can copy the ID of an existing object and paste it into the delete request. Hit send. It worked. The item has been successfully deleted. We check the database to ensure that it's indeed gone. And call the get function to verify that that object is also gone. Now we're ready to move on to create a React app. Okay, let's use the npx command to create a new React app. Here we're using npx create React app function to create a front end. After everything is done, I should be able to start the app. By default, it launches just a regular boilerplate image. Let's check it out. Okay, it works. Now we are ready to install Axios, which we're going to be using to communicate with our server. Start the app again. Now let's start some code. We want to create a new file called to-do list, which will be where we are running the to-do list app. Here I'm going to paste some code in here that pretty much just shows the to-do list items that are currently in the database. For that, I've added a state variable called to-do, and on init is going to call this function called get-to-dos, which makes a get request from the server and set the state variable. And this is the rendering code that displays the to-do items. I've added a checkbox that is checked if the to-do is completed. We're also adding a line through, cross out if the to-do is been completed, and finally we display the to-do name. Finally, we're going to update the index.js with the new component that we have just created. Okay, let's take a look. All right, looks like it works. Let's check the database. Now we can change the completed to true and see if it's rendered the way we want it to be. Hit save. Go back to the app and reload. Great, now we are ready to write some code that allows our user to create new to-do list item. Let's go back to the code here. I want to add a new state variable that contains the new to-do list item name. Then we're going to write a function to handle what happens when I submit the new to-do list item. Here we're creating a new post request to our endpoint with the new to-do list item name, and by default completed is false. After that, we'll set it to do. We'll reload the to-do list. Finally, I'll add a form here that allows the users to submit, to input the form, to input the new to-do name. And when it's on submit, we'll call the function that was just created above. Let's try it out. Let's add a new item called buy egg. It works. Add another one. Great. Let's check the database to make sure that it really works. Awesome. Now we're ready to do the next part. We want to implement a code that marks a to-do item as completed when the checkbox is toggled. To do that, we'll add a function called handle to-do completed change. First, it's going to find the to-do item associated with the checkbox. Then it will make a server call with a completed flag the opposite of the existing value. Afterwards, it will update the to-do list state variable with a new value. It does so by finding the to-do item by index, then replacing the array element with a new one. Next, we will associate the checkbox with the function that was just created. Now let's test it out. When I check an item, go back and check the database, the item is now marked as completed. Now we're going to implement the delete function. First, we need to add a SVG as a trash can. Now we're going to implement the delete function. Let me add a function called handle to do delete. It makes a server delete call with the ID associated with the to-do item you wanted to delete. Then it updates the to-do list state variable by removing the deleted item. Let's add a button with a trash icon and associate with the function that was just created. Great. Let's save it. The trash icon appears. When I click on it, the to-do list state variable is updated and it's gone from the database. Our last feature is to allow our user to update the name of an existing to-do item. For that, we need to introduce a flag called isEditing to each of the to-do items so that we know which one is currently in editing mode. Let's update how our to-do list state variable is created. When the page first loads, we retrieve the item from the server side. We'll set the isEditing flag as false for all of them. Next, we'll create a function called toggle editing. This function is called when the user clicks on the name of the item. This toggles the flag for the selected item in the state variable. Now we'll update the rendering to show a form in an input box if the editing flag is true. If not, it will render the span tag as usual. I'll update the span tag such that if the user clicks on it, it will call the toggle editing function. Finally, we'll add a function to handle the form submit when the input field for the to-do name is changed. In this function, we call the put endpoint, which sends over the new name from the input field. As you can see, the form is associated with the input field when it's submitted. It calls the function that was just created with the value of the input name. Let's test it out. I made a change to the existing list item, and the change made it through to the database.
Hopefully by now you have a good sense of how to build this very simple client-server web application on your computer. You can find the source code in the video description below. In the next video, I'll show you how to add type safety to this application and why it's important in the real world. Thanks for watching. See you next time.